Alright. This is Eccentric LDS. And it's actually LDS this time. But it's going to be tricky. We're going to look through 6 builds over the course of about an hour. The reason why we're putting so much energy into this is because we can look at our copper and see a numbing array of possibilities, but we'll get a production rate out of that at 6.5 plates from 1.2 thousand items per minute. On the steel side, we'll see 0.8 plates of steel at a rate of 1.8 thousand items per minute iron fluids. Steel's harder. Plastic wasn't analyzed because we saw that there were several recipes to get plastic. This produces a really rough scenario because research, building selected, and modules selected all affected what our outcome was on steel. So even though we're numb here, we do have to look at 6 different things. The way that the modules work is that they're metaphors for how we conduct our business on an assembly line. We can look at efficiency modules and eliminate those pretty quickly because they reduce energy consumption. And by eliminating energy consumption, we can safely scale this build horizontally by copy and pasting it. But that is not going to allow us to make a greater volume of quality items. So this is something that you would always do if you had the time. For speed, that noticeably reduces the rate. That creates a technical issue where if there is something to be had by processing a greater volume of material, that reduction has to be demonstrated on a case-by-case basis. Right now, we want to demonstrate the volume of parts we can produce in the first place. And then we could apply that reduction as a skill, if it benefits us. The metaphors we're looking at now are material handling and selection for quality. With material handling, it goes like this. We can produce more parts from a given unit of material. With legendary modules, we can produce so many that even though on paper it takes us longer to sift through materials, the effect of quality on that module is going to make it outperform our speed loss. We'll always lose energy doing this, though. So without these environment modules, expect your power grid to grow. With quality, it's a little bit different. We're always going to be selecting materials based off of their traits. That's what that bonus percent means. And the ratio of selection is going to be what produces an interesting volume of parts. So this has inspired 6 different builds. The builds are based off of module selections that are not mine. I want to make that very clear. This project is all about looking for reputable ways of doing this and doing this well. So what I thought would be good was to have a build that used 4 of the basic quality modules at Legendary, because I think that's where you'd go as a player if you had no other option, if you decided not to educate yourself by reading the wiki. This would be a good start. And so that's done throughout the depth of this assembly line. On initial production, on remanufacturing, it will always be done on recycling. Our second build in this series is going to be what happens if we spend the energy to calculate what appears to be effective for creating items and use that. This is what you're going to find on the wiki, and it's also present in Koninge's table of builds. They give different numbers for the outcomes of how effective this is, but it would be a good initial start. There's another entry on Koninge's tables, which gives us an intriguing idea. Why not go for items? And we do that by slightly modifying this end step here. For rares, and by putting in max modules on this. I believe that is table I in their spreadsheet. Alright, I did some testing on this before I committed to filming it. Just doing initial analysis, this Novice B seems like a good representation of what you would get. So what I said was, what happens if we change how initial production is done? Is that an optimization? Does that actually benefit us? That's going to be handled on the analysis section. There's going to be a video which is entirely initial reactions from looking at these raw material lines. With these cryo plants, I can set them up so they have the same productivity and quality as these foundries. Same with steel, although steel and plastic will both be affected by a productivity research themselves, so this is highly provisional. What you'll see on this assembly machine, though, is that's going to be using the wiki's suggested module mix to produce a number of items. It's going to require 3 more buildings going up and 1 more off to the side using full productivity, because if we get some legendary parts, we want to manufacture anything at legendary quality, although that happens very rarely on these builds. If you look at the wiki's suggested module mix for foundries, it's different. So we should track that and see how that changes things. This is going to factor into our analysis too, though, because since we can select for quality while stretching our materials out using productivity, we could, in theory, put a bunch of productivity modules into these foundries to get an exceptional rate of copper and steel back using our basic builds without doing this optimization or requiring extra buildings on this step. That will be looked at in analysis. It's great. I get 2 things to analyze for the price of 1. Just what I needed. there's also going to be an interesting variation, which shows what happens if you try and make an intuitive step by selecting for more quality instead of selecting for more productivity. Because the wiki does suggest that we do this somewhat intelligently, but what if we got just a slightly better rate of quality selected here? How will that benefit or hurt us in the long run? That's what's being looked at. If you don't want to hear technical particulars, then you can go right on to analysis or to watching the initial reactions of the build and a technical analysis of what you see and what you have to correct when you're running this. From a manufacturing point of view, I want you to imagine that a normal Factorio player starting out their game is doing a furnace stack. They look for 15 items per second out of about 24 to 48 buildings, depending on what level of research they're at and whether they have stone furnaces or steel furnaces. Our initial production step takes about, I want to say 4 to 6 buildings here. Just about 1 to 2 buildings here if you use cryo plants. And probably 1, maybe 2 buildings here, judging by products finished on this build. If we look at this section is going to make an item per second LDS if we have the faster quality modules in it, and slightly less if we have more productive modules in it. So that's sort of the basis for this build. It creates a technical difficulty here, though, at the point of remanufacturing. You end up needing a proportional amount of buildings to the amount of manufacturing you do here on this step. If we just look at the Novice series, it's 12 on these lines and 6 on normal quality specifically. So that's 1, 2, 3. If you want LDS, another 4 of 12. That's at about 48 buildings. With recyclers, the variance is even greater because at level 0 productivity, you need about 3 of these operating. At full productivity, I calculated as 19. The research build varies from 24 to 28. That's mainly because I need to see how many of these machines activate and destroy material, and these assembly lines have a habit of dragging material along a line. On that note, don't look at the belts. Don't go, oh, this is impossible spaghetti by looking at these belts. Don't even go, oh, we need to have, this level of turbos, belts. No. The way that this assembly line works is it's a science line. I need to be able to see how things interact when I build things up and copy and paste them. And that's so I can do continuous quality control as I'm filming this. So what you really can do is just build a straight line run of belts instead of copying and pasting a build and rotating it 5 times. That's just going to look a lot neater in the first place, and you will be able to scale more effectively based off of that by copying and pasting individual parts of this build as you get the items to do it. That's if you go for belts at all. It is a viable strategy to get super duper fast robot servants in this game, which will carry items back and forth. You'll need to use more power. You also will need to sort out how to manage a logistics inventory. But those are playstyle choices. We can have debates while drinking fine drinks like Gentry about how good one is or the other. That would massively reduce the size of this build. It would not reduce the amount of buildings you need, however. The rates are the rates. On that note, these assembly machine 3s are legendary. These recyclers are normal, so these sections could actually be reduced by a factor of 2.5 times at a huge cost. The last peculiarity of this build is that when we do this, and I want to get this running so you see how it's being done, we're doing this at a very advanced rate of time using the map editor. When this shreds something, it's going to create a random distribution of parts. So I can get some plastic out. If I freeze time here and look at this pile, though, you see I didn't get any steel out. So that's the effect of a random distribution being worked through time. That's why I have these large material buffers here. If your buffer fills up, it will go and be run through this line up to disposal. This is 7,000 parts over a 10-hour run. I'm fine with the lost materials. If you think different, you could use the upcycling builds from the copper and steel section and then figure out how to do plastic to recover material. It is an option to just throw it out, and I'm not seeing enough that I feel like it will produce a massive error in data. Materials are going to be handled a bit different, though, because at each section where we see recycling, we can get legendary raw materials out. At each section where we see remanufacture and even initial manufacture, albeit at a very low rate, we can see legendary parts going in. And just to demonstrate, this is a relatively new one, not so many legendary parts, a lot more parts coming out of this section. This all has to be filtered out and tracked and thrown into this section rather carefully, but we can use our production statistics to do that, and there's going to be a review of those statistics in the analysis section. On this pathway here, I'm filtering out all relevant parts and then putting them into a cycling section. And then filtering out copper, steel, and plastic appropriately on an individual basis. So I'm going to track all of the legendary copper, steel, and plastic this build is going to produce and accumulate those tallies separately, because it creates some interesting questions about the efficiency and effect of this build down the road, particularly since one build is supposed to be skewed for item production instead of for generating a specific end product. And with that introduction out of the way, I think you have a fairly good idea of what we're going to look at. So let's go on to the initial reactions of how the build performs at the end of its runs, and then to analysis.